All right, this is similar to the example we did on Monday before the snow.
Or that white oppressive snow king.
And we're done. Okay, starting now. Car travels in a straight line for 1 hour. Its velocity v in miles per hour at 6-minute intervals is shown on the table. 6-minute intervals. First thing that tells me is that's going to be our delta x. And this is going to be one where we can actually use the trapezoid rule because our delta x is going to be the same thing every time. Okay? So we're going to go in basically with the trapezoid rule. We're going to connect these dots with straight lines. So a car travels in a straight line for 1 hour. Its velocity v in miles per hour at 6-minute intervals is shown in the table. A, provide a reasonable graph of the velocity function v by graphing these points and connecting them with a smooth curve. I don't know if I like the smooth curve part. I'm just going to do a quick sketch. You don't have to be super precise with this. Why am I only focused on quadrant 1?
That's all
Positive,
where it is.
negative.
It's where it is. It's all positive. I don't see anything negative, etc., etc. Good. Okay, so I see we passed through 0, 0. Let me label my axis. This is t in hours. That's velocity in miles per hour. There could be a trick question that would be fair. If t is in seconds and velocity is in like miles per hour, you might have to do some converting, some units changing. But in this case, we don't. Okay, t in hours, so let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's my 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. What are these decimals doing here? I thought they said it was 6-minute intervals.
No, 6, but right? Did I read wrong?
6-minute intervals.
6. Yeah.
Okay, so why are these decimals here?
Because it's...
Oh, it's out of an hour?
Yeah.
it's out of an hour.
It's out of an hour, and what is 1/10 of an hour?
6 minutes.
6 minutes. So this is 6 minutes, 12 minutes, 18 minutes, 24 minutes. Okay, just double checking that you caught that. All right, so now for the velocities, I'm not going to be too picky on this about that you line it up perfectly with the y-axis. Just make sure that, you know, you got 10, 20 should be about twice as high, 40 should be about twice as high as that. At 0.4, we're at 60, not twice as high. At 0.5, he starts to slow down. He's at 50, so I'd like to see that halfway between your 60 and your 40. At 0.6, it's back down to 40. That's the same as over there, right? At 0.7, he's at 35. That's a good height for that. At 0.8, he goes back up to 40, same height as the other two. At 0.9, he's back up to 50. We hit that once before. 1.0, he's at 65. Is that the fastest he's gone?
65?
Yeah.
Yeah.
Okay. And if you wanted to connect this with a smooth curve, why a smooth curve?
Yes.
Okay. I would do something like, does that look like a smooth curve?
No.
What's the difference between that and normal curve?
A normal curve. A smooth curve wouldn't have any discontinuities. It wouldn't have any cusps. Wouldn't have a V like at the bottom of a absolute value. Yeah, Chris's is a little bit better. I totally missed that point there. All right. So that's A. Let's say that's reasonable graph B. Okay, so that's A. Now, let's start answering B. Find open intervals over which acceleration A is positive. Let's not write it in dotted because that will give me a headache, possibly even a seizure. Okay, B. When is the acceleration positive when you're looking at a velocity graph?
When the slope is positive.
When the slope is positive. Very good. So the acceleration is positive. Now, for our notation, I'm going to say, yes, I'm going to say bracket 0, 0.4. I could also say 0 to t. Actually, should I include 0.4?
0.4 is like flat. It should be less than 0.4.
Yeah, it should just be less than 0.4, which means, should this be a bracket?
No.
No. It should be a parentheses. Okay. That should be a parentheses, that's how you say included, not included,
That
okay? And then, but we don't really know for certain that, we're just guessing based
The left
on.
one's the bracket?
Sure, I would include 0, I would say it's 0, it's starting to accelerate. Maybe, I'll double check what the book says, but the way I'm reading it.
Is there a reason you didn't connect the blue line to the origin, or is that just what?
Oh, that was just being, that was just the pen being glitchy, actually, but you're right, I should do that. And I didn't connect the blue line to this point because I missed it. Try not to do that with your own pens and paper, but good question. All right, so anywhere else, where else would you say this is accelerating?
0.7 and up.
0.7 and up, including 0.7?
You can't really tell.
Can't really tell from the data, you don't really know, but based on the data, I
Based on
mean,
what you wrote it.
Does it matter?
yeah, it's different notation. Like if it's included 0.7, we would put the bracket. If it's not,
No, I mean overall.
it could. Depends on the question. For this question, I doubt it.
I don't think so.
But so 0.7, comma. Do we have any idea if 1.0 is included or not? Do we have anything that's speeding up or slowing down when it takes that picture?
It's going up. Isn't it?
Well, it goes up from 50 to 65. But what if it actually went up to 65 and then was
Going down.
well, basically we don't know what happens. Like what if he still started slamming on the brakes right here? Then this would be a point where the graph turned around. So I probably shouldn't have drawn it past there. I don't know. I'm going to guess included.
Which we're going to include again.
Yeah. We're not going to include 7 though, because I think you're supposed to think that that's a turnaround point.
Because it is going down.
Yeah.
It's 7, so it goes back up.
It seems to, but keep in mind, we have no idea what happens in between these points. But based on this information, those are my guesses.
Is it a half bracket, half parentheses? Even?
Parentheses means not included, bracket means included. Bracket means the same, that's what I wanted to review as well with this. Bracket means the same thing as equal to. So that is included with a bracket. That's a notation you should have seen before. It started somewhere around Algebra 1 or Algebra 2, and I know we did it a little bit last year. Bless you. Okay. All right. So basically these intervals though, from 0.4 from 0 to 0.4 and from 0.7 to 1. Any questions on that?
And
None.
Okay. Let's go on to the next one. I'll make a copy of this and just draw around it. Okay. Back to there. Whoops. One. Okay, number C, letter C. Find the average acceleration of the car in miles per hour over the interval 0 to 0.4.
Would that be the slope?
That would be the slope. Slope is average rate of change, derivative is instantaneous rate of change.
Do you take like 3 different slopes?
No, actually, believe it or not, it's simpler than that. That's what's deceptive about this. Do you think you'd like take these
That's
slopes
slope.
and average them?
Yeah.
But the actual average velocity from 0 to there is exactly that slope.
Oh.
That's it.
Wait, but we're finding the acceleration.
Average acceleration, thank you, I misspoke. Because this is a velocity graph, the average acceleration is just the slope from wherever you're beginning to care about your average.
So you would just
to where
take.
it
So we need to take 3 of them.
No.
For all the angles or not? You're like V over T change.
It's even simpler than that. Its acceleration is v2 minus v1 over t2 minus t1. And for the average over a whole interval, Jordan, all you care about is the endpoints. It's all you care about. We don't care about these at all. So we're literally just going to go, okay, 0.4, it was, notice this is also basically the same thing as slope is y2 minus y1 over x2 minus x1. If you had a picky Algebra 1 teacher, you might have heard the words that slope is average rate of change. You may have heard that. If you didn't, hear it now. Slope is average rate of change. So if you want an average velocity, an average acceleration, excuse me, it looks like this. We did this briefly in physics last year, but we weren't doing it in contrast to the derivative yet, because you guys hadn't learned what a derivative was yet. Okay, so for this exact one, Our average acceleration then is our velocity at point 4, which is 60, minus our velocity at 0, which is 0, divided by point 4, which is 0, and 60 divided by point 4, 4/10, 2/5, same as 5, divided by 2, 150?
Yep.
Okay, so that's 150, what would my unit be?
Miles per hour squared.
Yeah, miles per hour squared. Any questions on that? Clever of you guys to think about averaging all the other slopes, but you don't. For an average over that interval, it's just the whole thing.
Would it still work?
No, you'd probably get something different. Probably, kind of depends. If it did, it'd be coincidence. You can put it that way. Any questions on that one?
No, man.
Questions on the next.
Good.
Alright.
Good. Okay. Let me free up some space here.
Those trapezoids.
No, got more than I wanted. Never. Later that evening.
Does D imply that the velocity is the derivative of something?
Maybe. Hang on a second, let me read it again. Give me a Christmas break, a holiday break, and I suddenly don't remember how to work a bright link. What does D imply? Okay, we are up to D, okay. Put that down back in, and D. All right, what is the integral 1 to 0 v of t dt? Okay, this is our velocity graph, right?
Yeah.
What does an integral always mean?
Integer.
The antiderivative.
No, that's not what this is, you guys are, I fell for my trick. Pardon?
It's a region.
Area?
What about a region? Area of a region. Okay, the integral always means area of a region. Think of it as the absolute value sign analogy I always use. The integral, the absolute value sign, if you think of it as an instruction, it says make it positive, right? But it really means distance from the origin. And sometimes it's important to know that meaning. This always means, a definite integral always means
So
area.
it's displacement then?
Yeah.
Sometimes?
Just like in physics we talked about last year, the area under, slow down Cowboys, we go back.
Yeah.
Okay, if you see a definite integral, what it always means is area. How do we usually find that? We antiderive. Okay? But sometimes you can't antiderive. How do you antiderive a bunch of points? You can't. So,
You break it up?
you break it up into trapezoids, and in this case, but what it signifies,
And you use the area of the trapezoid to find the area.
to approximate. So you're only approximating at this point. But,
At some point throughout this area.
well,
Not a
your
problem.
calculator does something sort of like trapezoid or Simpson's rules to find the area when it does that very, very good approximation. You know how your calculator can just do this if you put in an equation. But for this case, we would need more data points to know how accurate or inaccurate it is. But what it signifies is the area, which on a velocity graph equals, what'd you say, Ike?
Displacement?
Yep. The area equals displacement on a velocity graph. On other graphs, it means other things.
Area over?
No, that's just me trying to separate things. I should not do that. Here, I know what I'll do. I'll use punctuation. Okay, so velocity graph, the area is displacement, so we have to find this. Now it just says, okay, approximate this integral using the trapezoid rule with 5 sub-intervals. 5 sub-intervals, cool, what's my delta V gonna be? My delta T?
The first one. 0 to 5 or 0 to 4. Or what?
5 sub-intervals. How are we gonna split 0 to 1 into 5 sub-intervals?
0 to 0.2.
Think that'll work?
Oh, yeah, 2 points. Oh!
And then 2 to 4,
I was thinking
4 to 6, 6 to 8, 8 to 10. Is that 4 sub-intervals?
Yeah.
And what does delta T equal?
2. Or
Try again.
You mean 5 sub
Well,
intervals?
2.2.
What did I say?
4.
Okay, sorry, yes, that was all the examples on Monday. You'll get 5 subintervals and delta t will be 0.2. Okay?
You know what I meant by 2.
I didn't know what you mean, but I wanted to make sure you don't write it that way on an AP exam in a few months. Okay, now the trapezoid rule just said, okay, so for the trapezoid rule, you can draw the trapezoids, you can find the areas separately, but it's much faster to just say the area is approximately, remember it was 1/2, first y value goes in once, second y value gets doubled. Wait, what y values am I actually using? I skipped a step,
You
I
didn't,
skipped a question.
you didn't put any UI values.
Okay, hang on.
The y values are the velocity.
They're from the tables, but what's the first one that I should use if we're using 5 subintervals?
10,
0, right?
Okay, the first one I should use is 0, that's correct.
well, yeah,
If I'm using 5 subintervals and I'm jumping to 0.2, what's the next one I should use?
oh, 20.
20.
Yeah.
The ones I'm gonna use 0, 20, 60, 40, 40 again, and 65. So when I fill this in, that's an easy trick to fall into. If your subintervals take you to every 2/10 of a hour, then you have to use every other data point. So this is going to be 2 times 20. Then we double the next one, which is 60. Then we double the next one, which is 40. Double the next one, which is 40 again. Last one we do not double.
Why not?
I went through that Monday on when we derived where this came from.
Double the first one or the last one.
Yeah, the short answer is,
Because it's not done twice. Right?
Because they
Yes.
share the same line between, nothing shares the same line as the first one.
that's the right idea, Andrew. When we go up here to this one, when we make these trapezoids, first off, our first trapezoid is a triangle, right?
Yeah.
Our next trapezoid
Oh, this is actually a closed trap.
looks like that. Our next trapezoid looks like that. It's starting to look like art. Our next trapezoid almost looks like a rectangle. And our next trapezoid goes all the way up to there.
But to be more accurate, couldn't you subtract that little triangle in the middle there?
Well, to be more accurate, what I would do is I would have used 10 subintervals.
For each one?
Yeah, just 10
I would've used
subintervals.
50.
And then you don't have any data for 50. You've only got 10
I
pieces
can
of
get
data. All right, you can, yeah, that goes well in science. Yeah, for better accuracy, I would have made a trapezoid here, 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 here. And as you put it so well, this would have been 2 trapezoids, and that little triangle would have been subtracted that way. So more intervals, more data always means more accuracy. Why are these doubled and the end ones not? This side is shared by 2 trapezoids.
Yes.
This side is shared by 2 trapezoids. This side, 2 trapezoids. This side, 2 trapezoids. This side, only shared in 1 trapezoid. Only appears once.
Okay.
This side of
Just
0.
Nothing to share.
Yeah, but if this were higher, it would only be on 1 trapezoid. It would only appear once. Okay, so calculator kids, what is this? Somebody should have the answer by now.
That's 38.5
I was
miles.
listening to you sometimes.
38.5
No, my calculator.
miles. Okay, and that's part,
Wait, that's not what I got.
double check.
I
Double check,
got
Chris.
192.5.
Even if you divide that by 2, that's
Multiply
off.
1 over 2.
What, I mean,
No, wait.
If you cut that in half, that's still not going to be
I
38.
multiplied by
I know what you meant, but okay.
Alright, I'll type it in.
Oh, isn't it 1 over 10?
what?
what?
Wait, where's the times delta? Oh, what did I leave out?
Times deltas.
I left out
Oh,
the times
true.
delta t. I left out the times delta t. So, after that, Chris, did you include that?
Yeah.
Good man.
Great.
Wait, do you have to multiply?
I didn't use my calculator right now, so I just said that.
Okay, so what I left out